Let's start with a very common JavaScript example. Imagine a junior developer working on a feature and trying to be as careful as possible. They write code that checks if a value is not null, not undefined, and not an empty string. The code works perfectly, and the big advantage here is clarity. Every edge case is spelled out, so even someone new to JavaScript can immediately understand what is being checked and why. This kind of code feels safe, predictable, and reduces the fear of unexpected bugs. However, the downside is that it quickly becomes verbose and repetitive. When the same pattern appears across many files, the code base gets noisy and harder to scan. Maintenance also becomes more difficult, because if the validation rules change, you need to update multiple conditions in multiple places. Now a senior developer looks at the same requirement from a different angle. Instead of listing every possible invalid value, they rely on how JavaScript actually works. In JavaScript, values like null, undefined, and empty strings are falsy, so a simple if name already covers those cases. The main strength of this approach is readability and intent. The code is shorter, easier to scan, and communicates the idea at a glance. It also scales better in large code bases, where reducing visual clutter has a real impact on long-term maintainability. But this approach is not magic, and it has its own trade-offs. It assumes that the developer fully understands truthy and falsy values, and it can introduce subtle bugs if values like 0 or false are actually valid inputs in the business logic. This is where experience matters. A senior developer is not blindly writing shorter code, but consciously accepting the trade-off and adjusting when necessary. The real difference between junior and senior code is not about syntax or shortcuts, but about understanding context, knowing the language deeply, and choosing the simplest solution that is still correct. Let's look at a very common situation when handling status values coming from an API. A junior developer usually reaches for a familiar solution and writes a chain of if-else statements to handle each possible status one by one. This approach feels safe and comfortable because the flow of logic is very explicit. You can read the code from top to bottom and clearly see what happens when the status is success, when it is error, and when it is loading. For small features or simple demos, this style works perfectly and is easy for beginners or new team members to understand. However, the weaknesses start to appear as the application grows. Every time a new status is introduced, the developer has to modify the control flow by adding another else if. Over time, this leads to longer functions, more branching, and code that is harder to scan and reason about. It also increases the risk of bugs, because changing logic in one branch can accidentally affect another. Now a senior developer looks at the same requirement and focuses on structure rather than conditions. Instead of controlling the flow with if-else, they create an object that maps each status to its corresponding handler function. This turns the problem into a data-driven approach, where behavior is defined by configuration rather than branching logic. Adding or removing a status becomes a simple, localized change that does not touch the main flow of the function. The use of optional chaining allows the code to fail gracefully when an unexpected status appears, without throwing runtime errors. The strength of this pattern is that it scales naturally, keeps the code clean, and makes long-term maintenance much easier. The trade-off is that it requires a deeper understanding of JavaScript concepts like object lookup and function references, which might be less obvious to junior developers at first glance. Once again, the real difference between junior and senior code is not about writing fewer lines, but about choosing an approach that stays clear, flexible, and maintainable as the system grows. This example shows a very clear difference in mindset between junior and senior developers. A junior developer often writes code in a very defensive and step-by-step way, first checking if the form exists, then checking if the form is valid, and finally checking if the form is not locked before calling the save function. This approach is not wrong at all. and in fact it closely matches how beginners naturally think through a problem. Each condition is explicit, easy to follow, and feels safe because nothing is assumed. However, as the number of conditions grows, this style quickly leads to deeply nested if statements, making the code harder to read, harder to scan, and more difficult to maintain over time. On the other hand, a senior developer approaches the same logic by flipping the perspective completely. Instead of asking when the code should run, they ask when the code should stop running. By using early returns, the function exits immediately when the form is missing, invalid, or locked, and only the happy path remains visible at the bottom of the function. This makes the code flatter, cleaner, and much easier to reason about at a glance. The big advantage of this approach is readability and maintainability, especially in real-world production code, where functions evolve and conditions change frequently. The potential downside is that it assumes the reader understands logical operators and early return patterns well, which may be less intuitive for beginners at first. Ultimately, this example proves that senior code is not about writing clever or complex logic, but about reducing cognitive load, making intent obvious, and designing code that is easy for future developers, including yourself, to understand and modify months or even years later. This example highlights another classic difference between junior and senior thinking when working with objects in JavaScript. A junior developer often starts by creating an empty object and then manually assigns each property, such as name, age, and role, one by one from the source object. This approach feels very concrete and reassuring, because every field is clearly visible and nothing happens implicitly. For someone new to JavaScript, this style makes it obvious what data is being copied and reduces the fear of accidentally including unwanted properties. However, as the codebase grows, this pattern quickly becomes a maintenance burden. Every time the user object changes, new fields are added, or existing fields are renamed, this block of code must be updated manually, increasing the risk of bugs and inconsistencies across the application. A senior developer looks at the same requirement and focuses on the true intent of the code, which is simply to create a copy of an object. By using the spread operator, the code becomes much more expressive and future-proof, automatically adapting to changes in the object structure without extra effort. The main advantage here is scalability and reduced duplication, which are critical in real-world projects where models evolve constantly. At the same time, a senior developer is also aware of the trade-offs, understanding that the spread operator performs a shallow copy and that nested objects will still share references. This awareness allows them to choose the right tool, depending on whether immutability or deep cloning is required. Once again, this example shows that senior code is not about writing less code for the sake of it, but about writing code that clearly communicates intent, minimizes long-term maintenance cost, and remains resilient as the application grows and changes over time. If you enjoyed this breakdown and found it useful, don't forget to like and follow the channel for more real-world coding insights. In the next video, we'll continue comparing junior and senior code with even more practical JavaScript examples that you'll definitely encounter in real projects. So stay tuned, keep coding, and I'll see you in the next one.